Within this lesson, we will work on multiplying decimals with an area model. For our first problem, we will look at 3 times 0.415, or 3 times 415 thousandths. In order to set this up, we will go ahead and use an area model, where it is that we're multiplying with that whole number, that 3 times that decimal, 0.415, or that's 4 tenths. We will decompose that number or break it apart. So we have 4 tenths, we have 1/100th, and we have 5 thousandths. And what we will do at that point is that we will go ahead and multiply by 3. We're multiplying by 3 here. And that's multiplied by 3. 3 times this number, 4 tenths, 1/100th, 5 thousandths. And then so we're going to multiply each of those places by that 3. So 3 times 4 tenths, 3 times 4 tenths, 3 4/10ths is 12. 3 times 4 is 12. That's 12 tenths. And 12 tenths as a decimal is 1.2. And what we will do is we will add that together to the other products that we get. 3 times 1/100th is 3/100ths. And the way that we write 3/100ths as a decimal is 0.03. Finally, we have 3 times 5 thousandths, which is equal to 15 thousandths. And to write 15 thousandths as a decimal, if we have 15 thousandths, then that is 0.015. And then what we have to do is we have to make sure to add those correctly. We have 5 thousandths. In the hundredths place, we have 1 plus 3 plus, that's it. So we have 4 there. And then in the tenths place, we have a 2, and in the ones place, we have a 1. So it's equal to 1.245. What you might want to have done is to actually have written these out vertically, and to make sure that they have the same amount of decimal places. And this is what I mean by that. And if we had done that, then it's less likely that we're going to end up making a mistake when we are carefully adding them together. Here we have the problem 3 copies of 5.35. This is a multiplication problem as well, where it is that we are taking 5.35, or 5 35/100ths, and multiplying it by 3. Again, we will set up that area model where we are multiplying by 3, and then we will break apart the 5 35/100ths into its parts. So we have 5 ones, 3 tenths, and 5 hundredths. We are then multiplying each of those values by 3. So we have 3 times that 5 ones, which gives us 15 ones. The 3 times the 3 tenths, which is equal to 9 tenths. And then 3 copies of the 500, or 3 times 5, which is 15 hundredths. Our next step is that we are going to go ahead and figure out the decimal equivalent for each of those. That's 15 there. I'm going to add the hundredths place in there. So the 15.00. The 9 tenths, which is 0.9, and I'll also add a hundredths place, and you will see why in a second. And we have 15 hundredths, which is written as 0.15. I will rewrite this so that I can go ahead and add them together. That's 15.00, that 15 ones, plus that 9 tenths, which is also equal to 90 hundredths, and the 0.15, or 15 hundredths there. Add them together, you get 5, 9 plus 1 is 10, 0, regroup the 1. 1 plus 5 is 6. And then so 3 copies of 5 and 35 hundredths is 16 and 5 hundredths. Here I have the problem of 6 times as much as 12 and 25 thousandths. I will break this apart again using my area model. I'll go ahead and write my 6 there because that is my whole number that I am multiplying by. I have 110. It looks like I have 2 ones within 12.025. Next I have a 2, and that 2 is in the hundredths place, so that's 2 hundredths. And finally I have 5 thousandths. So I can break it apart into unit form, and then I'm just going to go ahead and multiply by that 6. 6 times 110. 110 was already, so 1 times 6 is 6 tenths. What is 6 tenths worth? Right, 60. 2 ones, 6 times 2 is 12. Make that a little bit bigger there. So we have 12 ones, which is equal to 12. Remember that we add those two together. I know that I'm going to get 72 there. I'll evaluate that already. 6 times 2 is 12 hundredths. And finally, we have 6 times 5, which is 30, and that's 30 thousandths. I'm just going to be a little lazy. I'm going to write that label in there like that. 12 hundredths is equal to 0.12. 30 thousandths is equal to 0.030. 30 thousandths. I'll add a 0 there to add those two together, and then I just add it to my whole number. So I have 0.150 plus the 72 is 72.150 for 6 times as much as 12.025, or 12 and 25 thousandths. Here is one for you to try. We have 4.208, or 4 and 208 thousandths, times 6. We did break it apart for you with the times 6 here, and we've got 4 ones, 2 tenths, and 8 thousandths. Remember, you have to go 6 times 4 ones here, 6 times 2 tenths here, 6 times 8 thousandths here. You write what those are in standard form, that is within decimals, and make sure to add them together correctly. Pause the video, work out your problem. For the first little box here, we would have 6 times 4, which is 24 ones, 6 times 2, which is 12 tenths, and we have 6 times 8, which is 48 thousandths. And hopefully you wrote that out correctly. Next, we have to write the standard form, or the decimal, for each of those. 24 ones is pretty simple there. Plus 12 tenths, which should be 1.2. That's 12 tenths, what's what that's worth. And then we have 48 thousandths. That's 0.048. 48 thousandths. And then I just had to add those together. I get 25.2 from the 24 plus the 1.2. And then I'll go ahead and rewrite that there, like that there. It'll just be easier for me to show that work as I'm adding them together, so that way I make sure I do not make a mistake. So I get 25.248 as my answer, which is 25 and 248 thousandths. Here is another one for you to try. 15.06 times 5. Again, use the area model, set it up, and work it out, please. I have 15.06, or 15 and 6 hundredths, broken down into 110, 5 ones, and 6 hundredths. 5 times that 1 is 5, so I get 5 tenths. 5 times 5 is 25, 25 ones. So 5 tens is worth 50, 25 ones is worth 25, and I still have one more thing to do. I know that that's 75, and I just have to have 5 times 6 hundredths, which is 30 hundredths. And 30 hundredths is written as 0.30. So I end up getting 75.30 as my answer there, which actually does make sense. I'm going to use a standard algorithm just to show you this work again. 15.06 times 5. There always is more than one way to do a problem. 5 times 6 is 30. 0, regroup the 3. 5 times 0 is 0. Plus 3 is 3. 5 times 5 is 25. 5, regroup the 2. And 5 times 1 is 5. Plus 2 is 7. Since there are 2 decimal places within those factors there, we get 2 decimal places within our answer of that answer again as 75.30. Here I have one more decimal for an 952 thousandths times 8. And then so 8 is my whole number. That's why it goes on the outside here. And remember, the first thing that I do is I break down 4 and 952 thousandths into unit form. And we could choose any unit form as long as that value of that unit form, of course, is correct. However, I'll choose the easiest one, where I'll break it apart into each of its parts. 4 ones, 9 tenths, 5 hundredths, and 2 thousandths. As I continue there, we then take this 8, that's what we were multiplying by. I wonder if we should just put a times 8 there, so that we remember. 8 times 4 is 32 ones. 8 times 9 is 72, so we have 72 tenths. Remember that 10 tenths already equals 1, so 72 tenths is 7.2. 8 times 5, which is 40, and so we have 40 hundredths. And then so 40 hundredths is worth, let's see, 40 hundredths. Sorry. Is worth that right there. 0.40. 40 hundredths is worth 4 tenths, or 0.40 for 40 hundredths. And then, of course, I have 8 times 2, which is 16 thousandths. To be a little lazy there, I'm not going to write out that rest there. 16 thousandths is written 0.016. Let me add these two decimals together to get 0.416. 32 plus 7.2 is 39.2, plus the 0.416, I evaluate that, I get 39.616 as my product. Remember, the product is the answer to a multiplication problem. One of the things that we can do here, of course, is to use a standard algorithm to check. However, this lesson is to show you how it is that we can use an area model. Break apart a number, and we just multiply each of those parts.